Hello guys, our lesson today is about fractions. A fraction is written as a over b, where a and b are two integers and b is different than 0. Pay attention, a fraction with a denominator of 0 is undefined. A and b are the terms of the fraction. You are familiar with simplifying fractions, and you already know that to simplify a fraction means to divide its numerator and denominator by the same common divisor. Example 64 over 20 can be simplified. That's why we call it irreducible fraction. Both 64 and 20 are even, so the first divisor you must think of is 2. Divide 64 by 2 and 20 by 2. The new fraction is 32 over 10. 32 over 10 is a reducible fraction, since both terms 32 and 10 are even. So divide both terms by 2. The answer is 16 over 5. This fraction is irreducible. 16 and 5 are relatively prime, since 1 is their greatest common divisor. Fractions can be reducible. If a and b are not relatively prime, then the fraction is a reducible fraction. Example 32 over 40. Both 32 and 40 are even, so I can divide both the numerator and denominator by 2. 345 over 600. Both the numerator and the denominator can be divided by 5 in this case. 18 over 21. Both the numerator and denominator can be divided by 3, since 8 plus 1 is equal to 9 and 2 plus 1 is equal to 3. 9 and 3 are both divisible by 3. A fraction can also be irreducible. If a and b are relatively prime, then the fraction is an irreducible fraction. Example 7 over 10. 7 and 10 are relatively prime. Their greatest common factor is 1. So 7 over 10 is an irreducible fraction. 14 and 33 are also relatively prime. Therefore, 14 over 33 is an irreducible fraction. 5 and 9 are also relatively prime numbers. So 5 over 9 is an irreducible fraction. To reduce a fraction is to replace it by the irreducible fraction equal to it. There are three practical methods for reducing a fraction. The first method is the method of successive divisions. Divide the numerator and denominator of the fraction by the same number until you obtain an irreducible fraction. 108 and 144 are both divisible by 2. The obtained fraction is also reducible. 54 and 72 are both even, so I divide 54 by 2 and 72 by 2. 27 and 36 are both divisible by 3, and so are 9 and 12. The irreducible fraction obtained at the end is 3 over 4. The second method is the method of prime factorization. Find the prime factorization of the numerator and denominator, then simplify. 108 over 144 is equal to 2 to the power of 2 times 3 to the power of 3 over 2 to the power of 4 times 3 to the power of 2. It's equal to 3 over 2 to the power of 2, which is equal to 3 over 4. And the last method is the method using the GCF. Find the GCF of the numerator and denominator. Divide the numerator and the denominator by the GCF. The GCF of 108 and 144 is 36. So divide 108 by 36 and 144 by 36. The answer is 3 over 4. Equivalent fractions. Upon multiplying the two terms of an irreducible fraction by the same non-zero whole number, a fraction equal to it is obtained. Let a over b be an irreducible fraction. If you multiply a by k and b by k, k being different than 0, we obtain an equivalent fraction. Example 3 over 5. 3 times 4 over 5 times 4 is equal to 12 over 20, which is an equivalent fraction of 3 over 5. In this case, the quotient of a over b does not change since its numerator and denominator are multiplied by the same number. 3 divided by 5 is equal to 12 divided by 20 equals 6/10. Note that the value of a quotient a over b does not change if its numerator and denominator are multiplied or divided by the same non-zero number. A and b are two numbers where b is different than 0. The quotient of a and b is denoted by a divided by b or a over b. A over b is a fractional writing. If a and b are whole numbers, the quotient a over b is a fraction. If the division of a by b ends, then the quotient is a decimal number. Among the following, which are fractions, justify? 3 over 5 is the only fraction, since 3 and 5 are whole numbers. 2 and 3/10 and 1 and 8/10 are not whole numbers. Therefore, 2 and 3/10 over 7 and 1 over 1 and 8/10 are not fractions. To write 2 and 3/10 over 7 as a fraction, simply multiply the numerator and denominator by 10. 2 and 3/10 times 10 over 7 times 10 is equal to 23 over 70. 23 over 70 is an irreducible fraction. Similarly, 1 times 10 over 1 and 8/10 times 10 is equal to 10 over 18. 10 over 18 is a reducible fraction. Divide the numerator and denominator by 2 to obtain the irreducible fraction, which is 5 over 9. Calculate the decimal writing, or the approximated writing, rounded to the nearest hundredth, of 3 over 7 and 41 over 14. You simply have to divide 3 by 7 and 41 by 14, and then round the answer to the nearest hundredth. The answers are respectively 43 hundredths and 2 and 93 hundredths. Rational numbers. A rational number is a number that can be written in the form of a over b, where a is an integer and b is a non-zero integer. Every terminating decimal is a rational number. Negative 3 and 2/10 is a rational number, since it can be written in the form negative 32 over 10. Every natural number is a rational number. 7 is equal to 7 over 1. Any periodic number is a rational number. 3 and 6,666 10,000 is equal to 11 over 3. Where 6 is repetitive, this number is called an infinite periodic number. Any infinite non-periodic number is not a rational number. Rational or irrational? 7 over 3 is a rational number since 7 and 3 are integers and 3 is different than 0. Negative 8 over 3 is a rational number since it is a terminating decimal. The third number is an irrational number since it is an infinite non-periodic number. 2 and 15 hundredths is a rational number since it is a terminating decimal. This number is a rational number since it is a decimal that can be written as a fraction with a denominator of 100,000. Negative 4 over 9 is a rational number since negative 4 and 9 are integers and 9 is different than 0. 3 is a rational number since it can be written as 3 over 1. Now, I'm going to explain to you the difference between decimal fractions and non-decimal fractions. Any fraction a over b where the division of a by b ends is called a decimal fraction. Such fraction can be written in the form of a fraction having its denominator a power of 10. Example 7 over 5. Since 7 divided by 5 is equal to a terminating decimal, which is 1 and 4/10, and 7 over 5 can be written as a fraction with a denominator of 10, this is a decimal fraction. Non-decimal fractions. Every non-decimal fraction is written in the form of a number with a decimal point in which the decimal part is repeated or periodic. Example 37 over 3. Since the quotient of 37 over 3 has a decimal part that is repeated, this fraction is called a non-decimal fraction. Practical methods to recognize whether a fraction is a decimal or not. The first method is to simplify the fraction so that it becomes irreducible. If the obtained fraction can be written in the form of a fraction whose denominator is a power of 10, then the given fraction is a decimal. In the first example, the irreducible fraction of 42 over 84 is 1 over 2. 1 over 2 is equal to 5 over 10. It is therefore a decimal fraction. In the second example, the irreducible fraction of 24 over 40 is 3 over 5. 3 over 5 is equal to 6 over 10. It is therefore a decimal fraction. But in the last example, the irreducible fraction of 57 over 42 is 19 over 14. 14 cannot be changed into a power of 10. Hence, it is not a decimal. The second method is to reduce the given fraction. Write the denominator of the obtained fraction as a product of prime factors. If only 2 or 5 are obtained as prime factors, then the fraction is decimal. In the first example, the irreducible fraction of 42 over 84 is 1 over 2. Then this fraction is a decimal fraction. The irreducible fraction of 24 over 40 is 3 over 5. It is therefore a decimal fraction. In the last example, the irreducible fraction of 57 over 210 is 19 over 70. 70 is equal to 2 times 5 times 7. Then this fraction is not a decimal fraction. That's it for now. Thank you for watching.